This presentation introduces VMware's software-defined enterprise-class storage solution, vSAN. vSAN powers industry-leading hyper-converged infrastructure solutions with a vSphere native high-performance architecture. The landscape in IT is continually changing. VMware's goal is to deliver the absolute best storage platform from end to end. This starts with the core storage data services. We've delivered deduplication, compression, encryption, erasure coding, and a plethora of other features that make the storage solution for data centers of today and tomorrow. Next are the critical infrastructure management pieces. Taking advantage of the most popular unified management platform in vCenter, we've introduced advanced health service checks, integrated performance monitoring, and hardware compatibility checks. As we look ahead, analytics are playing a bigger role in how we think about the evolution of vSAN. With the popularity of cloud-native apps and big data, vSAN is also a perfect fit for these applications. Let's start by taking a look at the architecture of vSAN. vSAN is VMware's software-defined storage solution built from the ground up for vSphere virtual machines. It abstracts and aggregates locally attached disks in a vSphere cluster to create a storage solution that can be provisioned and managed from vCenter and the vSphere web client. vSAN is hyper-converged. That is, storage and compute for VMs are delivered from the same x86 server platform running the hypervisor. Industry-standard components are used with direct attached storage devices from spinning disks to SSD to latest NVMe technology. vSAN integrates with the entire VMware stack, including features like vMotion, HA, DRS, etc. VM storage provisioning and day-to-day management of storage SLAs can be all controlled through the VM-level policies that can be set and modified on the fly. vSAN delivers enterprise-class features, scale, and performance, making it the ideal storage platform for virtual machines. A wide variety of deployment and configuration options make vSAN a flexible and highly scalable HCI storage solution. A single vSAN cluster consists of any number of physical server hosts from 2 to 64. Organizations can start with what is needed today and add additional compute and storage capacity as needed. Each host contains either all-flash devices, called all-flash cluster, or a combination of magnetic disks and flash devices, called hybrid cluster, that contribute cache and capacity to the vSAN distributed data store. In an all-flash cluster, the cache tier is used entirely as a write buffer. The cache tier in a hybrid cluster is divided into 70% for read cache and 30% for write buffer. Each disk group contains one cache device and 1 to 7 capacity devices. All flash vSAN clusters can achieve additional space savings using deduplication and compression. HCI Powered by vSAN makes it very easy to incrementally add compute resources and storage capacity to a cluster. Drives can be added to existing hosts, assuming empty drive slots are available. It is also possible to replace older drives with larger ones to increase capacity. In some cases, this can also boost performance by adding more cache to the faster storage technologies. Adding drives to an existing vSAN cluster is commonly called scaling up. Another option is scaling out, by adding new hosts to a cluster. This can be done without disruption and adds both compute resources and storage capacity to a vSAN cluster. Having the option to scale up and scale out gives administrators flexibility to add the right amount of resources as they are needed. How a hyperconverged solution is implemented matters. Some solutions provide an HCI solution using a virtual appliance pinned to each host in a cluster to provide storage services. But this comes at a significant cost to the user, as the number of effective VMs per host will be significantly reduced and the performance of the VMs will be more inconsistent. VMware vSAN takes advantage of being integrated directly into the kernel to offer supreme levels of efficiency, performance, and integration. This translates into a significant increase in the number of VMs per host as compared to the virtual appliance-based HCI solutions, with better, more consistent performance. Since vSAN is integrated into the hypervisor, it's aware of all the hypervisor activities and understanding of cluster topologies. This drives down the operational complexity and is easy to adopt into an organization because it is software that the user already knows. Remote offices and branch offices, ROBO, is a common geographic model for many organizations. vSAN makes it easy to run a 2-node vSAN cluster to provide all of the storage needs in these branch offices, while using the primary site as the location to house the witness appliances. This makes for a fast, affordable, and flexible management and delivery of services in environments that require this type of topology. Additionally, vSAN Robo Edition licensing has no host limit restriction. There is only a restriction of the number of VMs that may be run in a site. A maximum of 25 VMs can be run in a single site or across sites. Any multiple of 25 requires an additional 25 VM pack license. There is no upgrade path from vSAN Robo licenses to regular CPU or desktop vSAN licenses. vSAN 6.6 adds a major new capability, delivering a highly available stretch cluster that addresses the highest resiliency requirements of data centers, support for local failure protection. In 6.6, vSAN can now provide resiliency against both site failures and local component failures. With this, if a site fails, on the surviving site, the data remains highly available with host and disk group protection. This is supported on both all-flash and hybrid vSAN configurations. In addition, key advantages of our approach remain, including simple control through policy-based management, per VM granularity, and the ability to enable or disable non-disruptively. This low-cost protection reduces the stress on IT budgets by delivering highly available, economical, stretch clusters that are up to 50% less than leading traditional storage solutions. With a comprehensive stretch cluster solution, customers can confidently extend the cost and simplicity benefits of HCI to solve disaster recovery and business continuity needs. vSAN can either be deployed as an integrated system with dedicated appliance nodes like VxRail or as a vSAN Ready node. vSAN Ready node is a turnkey solution consisting of a validated server configuration in a tested, certified hardware form factor for vSAN deployment, jointly recommended by the server OEM and VMware. vSAN Ready nodes are ideal as hyperconverged building blocks for larger data center environments looking for automation and a need to customize hardware and software configurations. Storage Policy-Based Management, SPBM, is a storage policy framework that provides a single unified control plane across a broad range of data services and storage solutions. This framework helps to align storage with application demands for your virtual machines. Let's take a closer look. Storage policies are created and managed using the vSphere web client. Policies can be assigned to virtual machines and individual objects, such as a virtual disk. Storage policies are easily changed or reassigned if application requirements change. These modifications are performed with no downtime and without the need to migrate virtual machines from one data store to another. SPBM makes it possible to assign and modify service levels with precision on a per virtual machine basis. Creating a storage policy is nothing more than defining what your requirements are for a VM or a collection of VMs. These requirements are typically around protection and performance of the VM. A new policy can be created in vCenter and accessible for use by any VM served by the vCenter server. The following figure shows a storage policy with 3 rules. The first rule, primary level of failures to tolerate, defines how many failures an object can tolerate before it becomes unavailable. The second rule indicates the failure tolerance method that will be used. This policy uses RAID 5/6 erasure coding to minimize capacity consumption. The third rule, object space reservation, enables administrators to reserve capacity for objects. Let's take a look at a few examples of how storage policies affect component placement. To keep things simple, each of the VMs in these examples contain a 100 GB virtual disk. The first VM has a storage policy assigned where RAID 1 mirroring is the fault tolerance method and primary failures to tolerate equals 1. vSAN places a mirror copy of the data on separate hosts in the cluster. A small witness component is placed on a third host to serve as a tiebreaker should a split brain scenario occur. The second VM changes the failure tolerance method to RAID 5/6 erasure coding. As a result, 3 data components and a parity component are distributed across the 4 hosts to enable the disk object to survive the loss of a disk or entire host in this cluster. The next example shows a VM with a policy where RAID 1 mirroring is used and the primary failures to tolerate equals 2. In this case, vSAN places 3 copies of the data on 3 separate hosts and adds 2 witness components as tiebreakers. A primary failures to tolerate setting of 2 protects against the loss of 2 drives or hosts in a cluster. The last example changes the failure tolerance method to RAID 5/6 erasure coding while keeping primary failures to tolerate at 2. 4 data components and 2 parity components are distributed across the 6 hosts in this cluster to achieve compliance with the storage policy. The number of components and their placement is determined primarily by the failure tolerance method and primary failures to tolerate rules in a storage policy. vSAN distributes components across drives and hosts in the cluster based on the storage policy assigned to an object. This helps ensure virtual machine data remains accessible in the event of drive or host failure. All Flash vSAN clusters can take advantage of RAID 5/6 erasure coding, which consumes less capacity than mirroring. In this example, a 100 GB virtual machine configured as RAID 1 mirroring will consume a total of 200 GB, while the same 100 GB disk configured with erasure coding will only consume 133 GB. VMware's approach to HCI allows customers to protect existing storage investments while slowly evolving their IT to a software-defined data center. VMware's Storage Policy-Based Management (SPBM), the management engine for vSAN, extends per VM policies and automated provisioning to modern SAN and NAS storage systems as well, with virtual volumes (vVols). As a result, customers can connect their existing storage infrastructure to a vSphere cluster running vSAN, just like they do with vSphere today. Using proven, built-in technologies like Storage vMotion, customers can easily migrate data between the various storage solutions, enabling simple, non-disruptive migration plans. Now let's take a look at vSAN failure tolerance. VMware vSAN is an object-based storage system integrated into VMware vSphere. Virtual machines that live on vSAN storage are comprised of a number of storage objects. vSAN uses the concept of RAID tree to ensure protection of objects. A component is the leaf of an object's RAID tree and is how redundancy is provided to a given object. In this example, the object is a virtual disk with a VM storage policy configuration of RAID 1 mirroring and failures to tolerate equaling 1. This will require 2 replicas of the objects on different hosts, with a witness component acting as a tiebreaker. The ability to restore an object to its desired level of compliance for protection is a primary duty for vSAN. When a component is reported as absent, the object will remain available for use, but not in a redundant state. vSAN will identify components that go absent and begin a repair process to satisfy the original protection policy. Components will begin the repair process after 60 minutes from the time reported as absent. This timeout value helps alleviate unnecessary component repairs and rebuilds by planned activities such as maintenance mode or brief interruptions in network connectivity. After 60 minutes, vSAN will rebuild the absent component on another available host in the cluster to ensure the level of resiliency defined in the VM storage policy. In some cases, you may be aware that the maintenance window or failed object is going to last longer than 60 minutes, in which case you may want to choose the option to repair the object immediately. If, however, the component is inaccessible with error code sensed, for example a device failure, vSAN will begin the rebuild process immediately. vSphere HA provides the same level of protection for virtual machines on vSAN data stores as with traditional data stores. vSAN, however, uses its own logical network. When vSAN and vSphere HA are enabled for the same cluster, the HA inter-agent traffic flows over the storage network rather than the management network. If a host is isolated due to a network failure and the remaining hosts still have access to more than 50% of the VM's components, the VM will be restarted and the absent component will be rebuilt on an existing host. The purpose of any type of component resync or rebuild is to restore or ensure the level of resiliency defined for a given VMDK, VM, or collection of VMs. A number of improvements are included in vSAN 6.6 that assist in the rebuild process and placement of components, such as intelligent rebuilds using enhanced rebalancing, intelligent rebuilds using smart efficient repairs, intelligent rebuilds using partial repairs, and resumable resyncs. For more information, be sure to visit storagehub.vmware.com. Here we see a 12-node cluster and 2 VMs with 100 GB virtual disks. Both VMs are currently in compliance with their assigned storage policies. This means vSAN will distribute components that make up VMs across hosts to help ensure data is available when a drive or host fails. Each host in a vSAN cluster is an implicit fault domain. The administrator wishes to protect the VMs against the failure of a server rack. vSAN fault domains can be configured to achieve this requirement. As a result, vSAN will comply with storage policies by distributing components across fault domains, server racks in this case. After configuring vSAN fault domains, we see the first VM is not compliant. This is because 2 of the 3 components are located in the first server rack, which is configured as fault domain 1. As a result, vSAN migrates one of the components to another fault domain to comply with the assigned storage policy. This is the same case for the second VM, so vSAN migrates one of these components as well. Both VMs now comply with their assigned storage policies. Data belonging to these VMs will remain accessible if a drive, host, or even an entire server rack goes offline. Now that we have a basic understanding of how vSAN is implemented, let's spend some time on day-to-day operations. With vSAN, organizations are able to move away from having separate compute, network, and storage silos with separate teams and management tools. HCI allows organizations to greatly streamline management and combine teams into a more efficient group, with greater shared responsibilities and, more importantly, more time to spend on the growing list of strategic IT projects, not the tedious day-to-day tasks needed to simply keep IT running. As a result, vSAN can cut the amount of time spent on admin tasks by up to 50%. IT shifts from different silos to a converged infrastructure with a single tool that can manage compute and storage. Within that one tool and team, admins can configure, check health, monitor performance, and conduct capacity reporting simply and easily. VMware has taken a holistic approach when looking at the deployment, operation, and optimization of a vSAN environment. Everything from day zero deployment activities to daily operations have been integrated with vSAN to improve efficiency and lower operational costs by up to 80%. Let's take a closer look at each of these features, starting with VSAN Easy Install. Easy Install in VSAN 6.6 and newer versions provides a simple way to deploy vSphere, enable vSAN, and run a vCenter Server Virtual Appliance, or VCSA, on a single host. One or more vSAN disk groups are created as part of the wizard-driven deployment process, and the VCSA can be deployed to the vSAN data store. This avoids the need to procure and configure additional storage as part of the new cluster deployment. Once the wizard is complete, additional hosts can be added to build out the cluster to then begin the process of adding additional hosts to the cluster. The result is an easy-to-use wizard that is incorporated into the VCSA installer that can result in a rapid deployment of a greenfield vSAN installation. Once vSAN is deployed, data services for space efficiency, security, and compatibility with physical workloads can be enabled. These services include deduplication and compression, data at rest encryption, and the vSAN iSCSI target service. They are commonly enabled right after vSAN is turned on, but they can also be enabled later, even if there are existing VMs running on the vSAN data store. Deduplication and compression are enabled together to achieve greater space efficiency. These features are supported only with all-flash vSAN clusters. Deduplication and compression are applied when data is destaged from the cache tier to the capacity tier. This approach provides space efficiency in the capacity tier while avoiding a potential performance hit in the active cache tier. Here we can see a VM writing data to the cache tier. As this data is destaged to the capacity tier, vSAN moves this data to memory and applies deduplication at a fixed block size of 4K. Deduplication and compression are performed in memory to achieve the best performance. Compression is applied after deduplication. Blocks of data that can be reduced to 2K or less are compressed. The deduplicated and compressed data is then written to the capacity tier. VSAN 6.6 introduced the industry's first native HCI security solution. vSAN offers data at rest encryption that is completely hardware agnostic. This eliminates concerns such as storing sensitive data in less secure, edge IT locations. Encryption is applied to the entire vSAN data store. All data written to a vSAN storage device, both at the cache tier and capacity layer, is fully protected with an AES 256 encryption. Other HCI solutions use a hardware approach with self-encrypting drives. vSAN does not require self-encrypting drives, which enables choice of hardware, lower cost, and simplified management. Key management is done through the integration with central key management services that are KMIP compliant. There is no more managing and keeping track of individual drive keys or drive pins that are commonly required with the self-encrypting drives. vSAN encryption will be fully compatible with the vSAN storage efficiency features such as deduplication, compression, and erasure coding. vSphere features including vSphere HA, Storage vMotion and vSphere replication work seamlessly with vSAN encryption. vSAN extends workload support to physical servers with the iSCSI target service. vSAN makes it easy to access vSAN storage using the iSCSI protocol with just a few mouse clicks in the vSphere web client. iSCSI targets on vSAN are managed the same as other vSAN objects with storage policy-based management. vSAN functionality such as deduplication, compression, mirroring, and erasure coding can be used with the iSCSI target service. CHAP and mutual CHAP authentication add an extra layer of security. VMDKs are exported as LUNs and managed using storage policy-based management. iSCSI initiator groups are used to control access to these LUNs. Utilizing vSAN for physical server workloads and clustered applications can reduce or eliminate the dependency on legacy storage solutions while providing the benefits of vSAN such as simplicity, centralized management and monitoring, and high availability. An important aspect of a healthy vSAN environment is ensuring correct configurations, device firmware, and device drivers. vSAN 6.6 introduced vSAN Configuration Assist to check hardware compatibility, burn-in testing, network configuration, vSAN configuration, and adherence to VMware cluster recommendations. Outdated controller firmware and driver versions are identified, and the option to download and install the latest supported software is provided. Driver and firmware upgrades to controller hardware can now be initiated by a single click and orchestrated across the entire cluster to streamline hardware lifecycle management. This feature eliminates the need for vendor-specific tools. Automatic downloads and notifications reduce management overhead and lower the risk associated with the manual processes. Participating in the Customer Experience Improvement Program, CEIP, enables VMware to provide higher levels of proactive and reactive customer assistance. Benefits of participating in this program include streamlined troubleshooting, real-time notifications and recommendations for your environment, diagnostics, and the potential to remedy issues before they become problems. vSAN Health is cloud connected. New health checks appear as new VMware knowledge base articles are created and published. An Ask VMware button is supplied in the user interface, which guides administrators to the relevant knowledge base article. This benefit is delivered without the need to upgrade vSphere and vSAN. Proactive Cloud Analytics provide administrators with the latest checks and remedies for optimal reliability and performance. vSAN features a comprehensive health service that actively tests and monitors many items such as hardware compatibility, verification of storage device controllers, controller queue depth, and environmental checks for all-flash and hybrid vSAN configurations. vSAN Health examines a number of metrics including network connectivity, hardware compatibility, cluster health, and capacity utilization. vSAN Health is enabled by default and configured to check the health of the vSAN environment every 60 minutes. If an issue is detected, a warning is immediately visible in the vSAN UI. Clicking the warning provides more details about the issue and, in many cases, an Ask VMware button, which brings up the relevant knowledge base article. Proactive monitoring and alerting in vSAN Health helps ensure the environment is optimally configured and functioning properly for the highest levels of performance and availability. vSphere administrators have turned to VMware vSphere Update Manager, VUM, for quite some time now to simplify and automate the patching and upgrading of vSphere clusters. In previous versions with vSAN, admins had to do a bit of research and perform manual steps before upgrading a vSAN cluster. The primary concern was verifying hardware compatibility with the new version of vSphere and vSAN. This was a manual process of checking the VMware compatibility guide to ensure the upgraded version was supported with the hardware deployed in that vSAN cluster. Those concerns and manual steps have been eliminated and automated. vSphere Update Manager generates automated build recommendations for vSAN clusters. Information in the VMware Compatibility Guide and vSAN Release Catalog is combined with information about the currently installed ESXi release. The vSAN Release Catalog maintains information about available releases, preference order for your releases, and critical patches needed for each release. When a vSAN-compatible update becomes available, a notification is displayed in vSAN Health. This eliminates the manual effort of researching and correlating information from the various sources to determine the best release for an environment. vSAN Performance Diagnostics analyzes previously executed benchmarks. Administrators can select the desired benchmark goal, such as the maximum throughput or minimum latency, and a time range during which the benchmark ran. Performance data is collected and analyzed. If an issue is discovered, it is reported in the vSphere web client, along with recommendations for resolving the issue. The Ask VMware button and links provide access to relevant VMware knowledge base articles. HCI Bench has API-level integration with vSAN Performance Diagnostics. Administrators run a benchmark test, and HCI Bench will save this information. Detailed results of the test, including supporting graphs, are easily retrieved from the vSAN Performance Diagnostics section in the vSphere web client. This integration simplifies activities such as conducting a proof of concept and verifying a new vSAN cluster deployment. vSAN Support Insight enables VMware Global Support Services to provide a more consistent support experience and faster resolution times. A number of data points are collected on premises. Private information such as host names and IP addresses are removed from the data, which is then transmitted to VMware for analysis. VMware Global Support Services can quickly view hardware specifications, recent changes to performance data, vSAN configurations, health check parameters, capacity utilization, and many other real-time and historical data points. Having this information reduces the time needed for gathering information, and it accelerates troubleshooting efforts. Customers benefit from the faster resolution times, and VMware can use this information to further improve vSAN. vSAN includes many graphs that provide performance information at the cluster, host, network adapter, virtual machine, and virtual disk levels. There are many data points that can be viewed, such as IOPS, throughput, latency, packet loss rate, write buffer free percentage, cache destage rate, and congestion. Time range can be modified to show information from the last 1 to 24 hours, or a custom date and time range can be specified. It is also possible to save performance data for later viewing. The performance service is enabled at the cluster level. The performance service database is stored as a vSAN object independent of vCenter server. A storage policy is assigned to the object to control space consumption and availability of that object. If it becomes unavailable, performance history for the cluster cannot be viewed until access to the object is restored. Access to a variety of performance metrics at multiple levels enables administrators to verify a cluster is running properly, troubleshoot performance issues if they arise, and help remediate these issues. Capacity overviews makes it easy for administrators to see used and free space at a glance. Deduplication and compression information is displayed. Information is also available showing how much capacity various object types are consuming. If deduplication and compression are enabled, details regarding space savings are also shown. Certified file services and data protection solutions are available from third-party vendors in the VMware Ready for vSAN program. Customers can easily extend and complement their vSAN environment with proven, industry-leading solutions. This certification provides customers with detailed guidance on how to complement vSAN with key partner solutions and the flexibility to extend HCI environments with additional software services. A list of certified offerings can be found in the VMware Compatibility Guide. vRealize Operation Manager 6.6 and higher includes pre-built dashboards for vSAN. Included are items such as vSAN operations, capacity, troubleshooting, and optimization dashboards. Views can be customized to include a wide range of metrics for monitoring vSAN. It is also possible to view vSAN and non-vSAN metrics together for comparison and troubleshooting exercises. Multiple clusters can be viewed on a single screen, which provides administrators a holistic view of their environment. Historical data and charts in vRealize Operations Manager make it easy to identify trends and make corrections before issues arise. Integration is a key benefit of VMware's SDDC implementation. A major advantage of HCI powered by vSAN is rapid support of new hardware technology. Unlike the longer, more complicated refresh cycle of traditional storage systems, server platforms rapidly adopt new hardware technologies. vSAN is fully committed to this rapid support so customers can benefit from the latest hardware advancements right away. As an example, vSAN supported Intel Optane's SSD the moment they were released. The Intel 3D Crosspoint technology delivers lower latencies and improved performance. The broad choice of new hardware platforms and a strong VMware ecosystem provides the fastest path to next-generation server platforms and storage devices. vSAN provides excellent performance and resiliency for a wide variety of virtual machine workloads. There are a number of use cases for vSAN, and the list is constantly growing. In this section, we will explore just a few of these many use cases. The vSAN engineering team has made a number of optimizations and enhancements to the latest version of vSAN. As an example, the deduplication and checksum algorithms have been tweaked to deliver up to 50% greater performance as measured by IOPS versus the previous versions when all flash and various data services are enabled. Latencies have also been reduced by as much as 35%. Greater all-flash performance means customers can further accelerate their business-critical applications and deploy more on vSAN with confidence. A large number of customers already run applications such as SQL Server, Exchange, SharePoint, Oracle Database, and SAP on vSAN with great success. vSAN is already present in thousands of private data centers worldwide. vSAN is also a key component of VMware Cloud Foundation, as well as our Amazon Web Services and IBM Cloud offerings. We are also seeing a number of use cases at the edge beyond traditional remote office and branch office applications. The Internet of Things, IoT, and verticals such as retail, manufacturing, and healthcare are all generating increasing amounts of data away from the main data center, making it more difficult and costly to harness and analyze. Organizations are sending increasing amounts of data from the edge back to the main data center and to public clouds. The traditional model of sending data from the edge back to central locations is getting more expensive and introduces complexity. There is a growing need to process data and make it available for use at the edge. This is referred to as a distributed IT approach. HCI Powered by vSAN can lower the cost and complexity of a distributed IT model. HCI takes advantage of lower hardware cost while delivering the performance and resiliency required for business-critical applications in private data centers, public clouds, and at the edge. Having the necessary compute and storage resources along with valuable data in remote locations such as stores, oil rigs, remote offices, distribution centers, and even the battlefield can lead to competitive advantage. Even though these resources are distributed, it is still possible to manage them from a central location to minimize the operational costs and overhead. Many organizations do not have adequate disaster recovery plans and infrastructure. In most cases, this is due to cost. vSAN can be configured as a stretch cluster across metro distances where network latency is less than 5 milliseconds round trip. This architecture provides resiliency against unplanned downtime situations that affect entire sites. vSphere HA is tightly integrated with vSAN and enables fast, automated recovery from a site going offline. vSAN stretch clusters are typically up to 50% less expensive than traditional stretched storage solutions. vSAN also makes great storage solutions for a disaster recovery site. It offers the necessary performance to quickly recover many workloads while minimizing cost and complexity. VMs can be replicated from a primary location to a DR site with vSphere replication. This per-VM replication technology can achieve RPOs as low as 5 minutes, and it supports the replication of hundreds of virtual machines. VMware Site Recovery Manager adds disaster recovery orchestration and is tightly integrated with vSphere, vSAN, and vSphere replication. The vSAN witness host is placed at the DR site. vSphere replication is configured between the stretch cluster and DR site. Combining a vSAN stretch cluster with Site Recovery Manager provides resiliency against local site failure and widespread disaster scenarios. The partnership between VMware and Amazon Web Services gives VMware customers the option to run workloads on AWS's global infrastructure without modifying their applications or deviating from their existing operational model. The offering consists of dedicated AWS hardware running the VMware SDDC stack, including vSphere, NSX, and all-flash vSAN. The infrastructure is delivered as a service and provides customers with unified management, including full API support, a platform to run existing and next-generation applications, and flexible billing options. Access is also provided to native AWS services such as object storage and database as a service. Recently added to the list of available add-on services is VMware Site Recovery. This offering enables disaster recovery as a service. Customers can avoid the cost and complexity of maintaining a secondary data center for DR. This service utilizes the proven technologies of vSphere replication and Site Recovery Manager. Another key area of preparing for tomorrow's IT needs is supporting containers and next-generation applications. There is an updated vSphere Docker volume driver for better native support directly through Docker APIs. This allows Docker to take advantage of the proven persistent storage capabilities of vSAN. New features available with this driver update include support for multi-tenancy, storage policy-based management, cloning, and snapshots. vSAN 6.6 is well suited for next-generation applications. Performance improvements, especially when combined with new flash technologies for write-intensive applications, enable vSAN to address emerging applications like big data. The vSAN team has also tested and released a variety of reference architectures for these types of solutions, including MongoDB, Splunk, and InterSystems Cache. Customers want to take advantage of container technology for running stateful, data-intensive applications such as databases and modern cloud-native applications. One of the significant barriers they face is the lack of persistent storage solution in the container ecosystem. It requires building a robust, elastic, and programmable storage infrastructure with the same level of security, data integrity, high availability, and storage services that are expected in a modern IT infrastructure. Project Hatchway addresses this gap in vSphere environments by offering storage infrastructure choices for container environments, including vSAN, as well as traditional SAN and NAS. Project Hatchway offers tighter integration with container orchestrators such as Docker, Swarm, and Kubernetes to meet the needs of the DevOps community. It enables developers to consume storage infrastructure as code with the freedom to choose the orchestrator of their choice. This approach abstracts the complexity of underlying storage infrastructure. Through Project Hatchway, data services such as snapshots, cloning, encryption, deduplication, and compression are available at a container volume granularity. Container storage is carved out of existing VM storage. This provides the enterprise capabilities, storage services, and policy-based management to container storage. A combination of container schedulers and vSphere storage delivers a complete solution for stateful, next-generation applications. VMware is uniquely positioned to provide the most complete solution for modern data centers. From the public cloud to the private data center to the edge, these offerings are available today and help customers gain a competitive advantage through modern IT. vSAN is at the core of these offerings. TCO is reduced by taking advantage of lower-cost server hardware while providing high levels of performance and availability. Features such as strong policy-based management, proactive health checks, cloud analytics, and integration with vRealize Operations Manager reduce operational costs. Customers can take advantage of new flash storage technology such as 3D XPoint on day one. vSAN also provides the industry's first native HCI solution for data at rest encryption, without the need for costly self-encrypting drives. vSAN is the industry's most complete solution for modern data centers.